Hi, I'm Karyn and my passion is elementary mathematics. My company helps schools and organizations host K-5 Family Math Night events. So these events are typically held in a gymnasium or a multi-use room where large groups of people come and do super fun hands-on activities in math. But gathering in large groups or even small groups is not an option right now. So I'm going to show you how to host your own personal family math night event. All right, I have adapted 4 activities from our kits. And I chose these activities because they can easily be done with materials and supplies that you have at home. So if you're watching this on our website, then you'll notice that there are some buttons and some links below. Okay, you're going to be able to cycle through each one of the activities that we do in your event, and that's where you're going to get all of the background information and the PDFs and so forth that you need. If you're watching this on YouTube, then I've included a link in the description that will take you to our website, familymathnight.com, where you can access all of those buttons and links as well. Okay, so when you cycle through those activities, you will notice, so you'll cycle through the activities by clicking on the button underneath here, and then you'll notice that there's going to be a whole bunch of PDFs that are associated with that activity. And the very first one is going to be the activity overview. It's going to look something like this. There's a little welcome note there, and then you're going to have the activity, and then it's going to tell you what the supplies, materials that you need for that activity are. And then it's going to go over a really brief description. What I say brief because the meat of the activity is going to come from watching the video associated with the activity. And then some of them have some background and other information for you. Okay, you'll notice also in that list of PDFs that's where you're going to get the activity sheets and other things that go with that activity. Now, I recognize that there are many of you that don't have access to a printer. Okay, I have solutions for that, and I'll talk about those solutions when you watch the videos of the activity. And I need to tell you that those solutions have turned out to be some of my favorite activities. And that's because I really believe that we need to give our children opportunities to take charge of their own learning. And you're going to find out how that happens through those solutions for not having to be able to print those activity sheets. Okay, underneath you're also going to see some play buttons, and those are the buttons that have the little triangle on them. Now, in our kits, we do everything by levels, beginning, intermediate, and advanced. And the grade bands that go with those levels, so the beginning is K1, the intermediate is 2nd and 3rd, and the advanced is 4th and 5th grade. And we also color code everything. So the beginning level activities are yellow, the intermediate are green, and the advanced are blue. So we decided to do that here as well. So you'll see underneath that the activities, you've got your beginning, intermediate, and advanced activities, and also some of those play buttons are color coded. Now that's because you may have a, say, a 3rd grader, and you don't really need to listen to the directions for the beginning level. You need to skip right over to the intermediate level. And so if you click on that play button that's green, then that's going to take you to the section that you need to hear. That said, there are 2 activities that don't have those color coding, and that's because it was easier for me to explain the activities all at the same time. Okay, the next thing I want to talk about is organization. Organizing your family math night or your family math day. So it is really important for me that you have a successful event. So I want you to think about this as planning a party. And you know that when you plan a party, there's a lot that goes into that, right? You have to think about the day and the time and the supplies that you need and the locations and all that sort of stuff, okay? So this is not going to be I'm going to plan the whole thing in one night. This is going to take several days of planning to organize your family math night event. Now, what I have done is I have created a checkoff sheet for you that walks through each one of the steps that you need in order to plan and have a successful event. At our events, we use fourth graders and up to run our stations. I call them our station facilitators. It's a fabulous leadership opportunity. They step up, they do an amazing job. They love the responsibility. So remember earlier when I said that we need to provide our children with opportunities to take charge of their own learning? I'm going to put this out as a suggestion for those of you who have fourth graders and up. I'm going to see if you would let them host or plan the event. All right. Let them take charge of putting the whole thing together. There's a checkoff sheet, and I actually wrote this checkoff sheet with them in mind. Okay, this is a good opportunity for them to do some real life skills, right? So one of the first things that happens is you're going to need to choose the date or the dates of your event. So are you going to do all of the 4 activities in one night, or maybe you want to split them up? Something to think about. You're going to need to choose the beginning and the end time of the event. Now, I've given you a tip here that the activities are about 15 minutes. But that said, when you watch the videos, you're going to see that you could possibly do some extension activities, or maybe you want to do the activities that requires that when you can't use the printer, so it's going to involve a little bit more work. So then you're going to need to adjust your times according to that. Okay, then you're going to choose a location. Now I know you're doing this in your home, but are you going to do everything at the kitchen table? Are you going to do the family room? Spread the activities out around the house. Okay, how is it going to be organized that way? Then you're going to decide the flow of your event. Hey, maybe you want to have a break in between. You want to serve a snack. And then you're going to gather the materials and the supplies. And again, that first PDF, the overview one, okay, it has the supplies listed there for you. I like to be super organized when planning these events because a lot is going on. So I like to put all of my supplies into a tub. Okay, that way on event night, everything's organized. All you have to do is pull out the tub and you're ready to go. It's much more efficient that way. Let's see. Then you're going to prepare the environment. So at our events, we like to use brightly colored tablecloths on all of the tables at our stations. When you walk into the environment, you open the doors and the families come in, it's like, wow, what's going on here? It gives it a fun feeling, and it creates a great ambiance, and it shows that something special is going on. So your family math night event at your house is special as well. So what can you do to kind of make the environment just a little bit different to show that something different is going on here? Will you decorate? Maybe you'll have little table tents on the table, and the table tents can give the name of each one of the activities. So think about how you want to set up the environment. And then of course you're going to open the doors to your event, and everyone's going to enjoy all the activities, and you're going to be organized because everything's going to go into the tubs, and the cleanup is super easy when you do it that way as well. So there is your event in a nutshell. You're going to use those buttons and those links below. If you watch, I do have a section at the very end of this video after the last activity that talks about one more thing that you can add to your family math night event. So don't forget to watch that as well. But right now, I'm going to take you through the activities. And the first activity that I'm going to take you through is called Dice Games. The dice game at the beginning level is called Tens Are Terrific. So I have a PDF for you that gives you additional versions of this game. We're actually going to be playing version 1. Now, the different games require dot dice and a number cube. If you don't have dot dice or a number cube, I do have a net, a PDF of a net that you can use to create your own dice. Or if you happen to have dot dice, but you want to make a number cube, you can make that on here, okay? If you don't have a printer, you can still make your dice, because all you need to do is trace 6 squares into this pattern, okay? You can add tabs if you like, and then cut out your own dice. Now here's the key about regular dice. Opposite sides add up to 7. So for example, let me take this. 5 plus what equals 7? And you flip it over, you're going to see that there's 2 there. 5 plus 2 equals 7. 4 plus 3 equals 7. And then 6 plus 1 equals 7. And the same is true on the number cubes. 4 plus what equals 7? 3. 2 plus... 2 plus what equals 7? Let me start there again. 5, and so forth. Okay, so when you are designing your dice, if you choose to do this, keep that in mind. This actually is a very great spatial activity, because if you do design your own nets, or maybe you want to do this anyway, see if you could fill in your dots or your numbers on the die before you cut it out. Then cut it out and see if you got it right. So very spatial activity there as well. Okay, so back to this. So this Tens Are Terrific version 1 just requires, back to all the versions, all they really require is your dice, a pencil, counters in 2 either different colors or different styles. You can see here I have pinto beans and elbow macaroni, and then a piece of paper. Now, if you do have a printer and you want to print out the recording sheet, okay, and the 10 frame, so here's my 10 frame under here, okay, I do have a link on here. You can go to this link right here and you can access these, but really all you need is just a piece of paper, because you can easily write the numbers 4 through 9 for each player on the paper, and you could easily draw your own 10 frame. Okay, that said, I'm actually going to use these here. Okay, so the game plays, and you're going to take turns with your partner, and you're going to roll the dot die. Okay, so let's say it's my turn. I roll the dot die 2. I'm going to put 2 counters on my 10 frame. 1, 2. I need to figure out how many more I need to get to make 10. That's where these guys come in. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and 8. I need 8 more to make 10. So because I need 8 more, I'm going to go over here to my recording sheet, and I'm player 1, and I'm going to put a tally mark next to 8 because I need 8 more. What you might want to do in advance is to remind your child how to record tally marks. Okay, you get to 4 and then you cross the 4 tallies. The first person to get to 5 tally marks is the winner. Okay, so now it's player 2's turn. Okay. Player 2 rolls a 6. So let's get 1, 2, 3, 4, 5, 6 on my 10 frame. How many more do I need to get to 10? 1, 2, 3, 4. I need 4 more. So player 2 gets a tally mark there. And again, back and forth until the first person gets 5 tally marks. Okay. If you want additional versions, you want to challenge yourself, okay, there are different versions to this game. All right, have fun. So I'm going to explain the directions to the intermediate and the advanced dice games at the same time because it's really the same game at 2 different levels. So you do have the directions as PDFs. Here's the directions for the intermediate, and here's the directions for the advanced. Let me make a quick comment about this. I did the best that I could with my printer to get this to stand out a little bit more. It is legible. It's just not as bright as I would like it to be. The original version, this is what the original version looks like. So it's nice and crisp and bright there. But again, it is legible. You can read it. I did the best that I can. I think it's just a printer, you know, my home printer issue. But you do have those that PDF for that. And we're gonna I'm gonna show you how to play version number 1 of each one of these games. It's called In Between. Now, each one of these levels comes with additional versions. So if you want more of a challenge, you can read those versions and play those games. You're going to need some, well, I call for number cubes. If you don't have number cubes, regular dot die will work just as well. If you don't have either one of those, I do have a PDF that you can print and create your own dice. I left them blank for you to be able to do that so that you can either create dot dice or number cubes depending on what you want. Now, what you do need to know here is that opposite sides of a regular die add up to 7. So if I have 5 on this face of my die, the other side, 5 plus what equals 7? 2 would have to be 2, right? If there's 6 on this side, the opposite side is 1, and so forth. And the number cubes work the same way. There's 2 on this side, the opposite side is 5. So when you are designing your dice, it's a great activity to actually think, spatial activity actually to try and figure out where those numbers or those dots go. Cut it out and then see if you got the opposite sides to add up to 7. Now, if you don't have access to a printer, but you do know how to draw squares, you can easily make your own dice out of paper by just drawing 6 squares in this pattern. I suggest adding tabs because it makes it easier to fold and tape that into your die. And you know what? This might be a fun activity to do regardless of whether or not you have dice, especially that spatial, you know, figuring out where the numbers go. Okay, so again, we're going to play version 1, and I'm going to start with the intermediate level. So each player, there are 2 players, is going to draw 8 dash lines. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And the object of this game is to get the lines filled in with numbers. We're going to be using 2-digit numbers, okay, from least to greatest. Okay, the first person to do that is the winner. How you're going to do that at the intermediate version is you're going to roll both dice. You're going to decide if you want to make that a 21 or a 12, and then you're going to figure out where you want. You can put it anywhere on this line, but remember, it needs to go from least to greatest, all filled in to win. Now, one of the things that you might need to think about is what's the lowest number that you could make with 2 dice? What's the highest number that you can make with 2 dice? Because that is going to be super important for you to figure out where to put your numbers. And since I've got a 12, I'm going to put my 12 right down here because the lowest number I can make is 11. So that's pretty darn close to that lowest number. That's a good spot for my 12. Okay, so now I could make a 26 or a 62. Now, if you think about it, the highest number that you could make with 2 dice is 66. So 62 is not bad. I might want to put my 62 here. And you keep going back and forth until you get them all filled in, least to greatest. If you're filling them in and you create a number and you can't put it on your line anywhere, then you lose that turn. Okay? Now, at the advanced level, same thing, 8 lines, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now we're going to practice our multiplication effects because we are going to multiply our 2 numbers together. So think about this. What is the lowest number that you could make when you multiply, when you're using the dice? What is the highest number that you can make? Because that's going to help you figure out where to put your numbers on here. Wow. Okay. So 6 times 5. Okay. The highest that I could get is 6 times 6 is 36, but 6 times 5 is 30. That's pretty good. And the chances of me getting a 6 times 6, well, you know, I could get it, but I'm going to put my 30 right here. And then our partner goes, oh, and they got the same thing. If they think they're super lucky and they want to put their 30 here and hope for a 6 times 6, they can do that. It's up to them. And so forth, back and forth until the first person gets it filled in. Least to greatest is the winner. Okay, if you want some challenges, remember, you can get those challenges on the different versions of that PDF that you have access to. So have fun. So I'm going to go over the directions for the beginning, the intermediate, and the advanced levels together, since the directions really apply to all of the levels. So you're going to need your Who Am I clues, and each level has 2 of those. Okay. You're going to need a piece of paper to cover them like this, because students are going to be going down like that and stopping before they answer the question. You're going to need your 0 through 110 number grid. Now you can see I put this in a gallon freezer bag because students are going to be using this to help them solve their problems. You can use a sheet protector if you have. You can see here that a dry erase marker works really well on this. A wet erase works really well on this, but you may not have a dry erase or a wet erase. So you can use a regular marker. It doesn't work as good, but definitely you can see that that number 27 is circled. So it will work. Okay, let me wipe that off. All right. So if you do not have access to a printer, you will need to write all these numbers down. Okay. Or your student, your child, can write those numbers down, or you can do it together because it's an awful lot of numbers depending on the grade level that they're in. All right, so let me just show you how we do this in our kit so you can understand why I have it printed this way for you. This is what they look like in our kit. And we do everything color-coded in the kit, so yellow would be beginning. But basically, they would pull this up, and they would stop where it says stop and think. They read, their parent, you read the question to them, especially at the beginning level, and then they would use this to figure out their answer. Okay. And then they would pull it up. I am the answer 9, and then they do the next one. And there's 3 on every page, and they're double-sided. Okay. Yours aren't, but those are. So that's why I have it like this. Now, if you have a child who may want to make their own pockets, okay, out of paper, that'd be a great project for them. They could cut this out to fit inside their pocket. They can use tape and so forth, and they too can pull it up and down. That would be a fun project for them to do. But basically, like I said, you're going to read the clues, and you're going to do some thinking, and you're going to see if you were right. Okay, so there's the beginning level. Now, at the intermediate and the advanced level, there's some vocabulary that we may need to review. So I have this sheet in here, and it's the same thing twice in case you want to share it.
But it just reminds them what the word product means, or what the word sum means, and so forth. So that is there for you to use. And then you've got your two, the two clues for the intermediate level. Now at the advanced level, I have this for you as well, because now we're getting into some number theory. In order to understand composite and prime numbers, you really need to understand what factors are. And a factor is a whole number that when you multiply them together, you get another number. So the factors of 8 would be 1, 2, 4, and 8. And this is a really good visual representation, okay, of that. You can see how we got, this is a rectangle made out of 8 squares in that direction. Can you make another rectangle for 8? Yes, we can. It's a 2 by 4, okay? And so 2 and 4 are the factors of 8. You use that information when you're talking about composite and prime numbers. So a composite number has more than 2 factors, and a prime number has exactly 2 factors. And by the way, 1 is not a prime number. So if you wanted to, and this is another math lesson, but if you wanted to, you could get a whole bunch of squares and you can figure out which numbers are prime and which are composite. So with those 3 squares right there, can I make 3 another way? Well, that's not a rectangle because I need to make it into a rectangle. That's not a rectangle, okay? That is the same as that. And by the way, this is the same as that. They're congruent, so we're saying those are the same. Okay, so that's another exercise. But prime numbers you can only do in one way. Composite numbers, you can make more than one rectangle out of it. And the reason I have it set up like this, it's the same thing on both sides, is because this is what we use in our kits. So it's double-sided. These are table tents. We put those up on the table so students can easily see that. So you can turn this into a table tent if you like. And that, then we've got our critical thinking questions. So down here, questions to get your kids to think at a higher level. Okay, awesome. And by the way, these are just starter questions. It's not the beginning, middle, and end, okay? This is just to jumpstart the conversation with your child. You're gonna have there's a lot of other questions that you can ask as well, okay? This is just starter. And then this here is my favorite part, because now your child gets to come up with their own clues and their own answers. Okay, and there's 3 of them for them to do on here. And they can share this with their siblings. They can see if their siblings can figure out what the answer is. They can share them with you. Okay, this is really fun, and it gets them to really think about numbers and number relationships. So enjoy this activity. So this is the beginning level spinner board. If you do not have a printer, after I go over these directions, you're going to skip over to the section on creating your own spinner board. And actually, I highly recommend that even if you do have a printer, you watch that section anyway, especially if you have upper elementary students or older. You may want them to create their own spinner board. There's a lot of math happening in the creation of this board, and it would be a great activity for them to do. Okay, if you have printed this out, you can use a sheet protector, okay, or a gallon freezer bag will work as well to protect that as you collect data with your dry erase or wet erase marker. Regular markers work as well. It's not as good as the other 2, but it definitely will get the job done. Okay, or you can simply draw a line down the center here, like this. Okay, and then you can create, this is going to be spinner A, this is going to be spinner B, and this is where you collect your data. Now, this activity is about probability and data collection. And probability is the chance of something happening. So your child's going to be making predictions looking at spinner A, which color they think is going to get the most checks. And whichever color gets to the top of the graph first, that's when you stop collecting data. So once they make their prediction and they talk to you about that, then you can put your pencil there, there's your paper clip, and you can start collecting data, okay? And then at the end of that, you can talk about the results and whether or not their prediction was correct. Now in spinner B, this is interesting because obviously each section has an equal chance of winning, right? But kids at this age, do not be surprised if they actually pick a color because it's their favorite color, right? And then they hope that that color wins. But what I want you to do is to talk to them as you're collecting the data and see whether or not the check marks are pretty even as they're going up. And you might even want to do this several times so that they can see that each one of these sections has an equal chance of winning. We're exposing them to that idea of probability. Now, the critical thinking question for this activity is to talk to your child about which spinner is fair, spinner A or spinner B, and how do you know? All right, so that's the beginning level activity. And again, I highly recommend that you watch the section on creating your own spinner boards. So this is the intermediate level spinner board. If you do not have access to a printer, then once I go over these directions, you're going to watch the section on creating your own spinner boards. That said, I highly recommend that you watch that section anyway. With your guidance, I believe that your second or third grader can create their own spinner board. There is a lot of math that's going to be happening during that activity, and I think is a well worth exercise for them to do. All right, so you're going to need crayons or pencils or pens in yellow, blue, red, and green. You're going to need a paper clip. Okay, so we're going to use as our spinner. And you're going to need a straight edge and a pencil. This activity is all about probability and data collection. And probability is the chance of something happening. So in part 1, your child's going to make a prediction. If you spin the spinner 20 times, which color, red, green, or yellow, do you think will get spun the most times? And why? Now they can color those in, and then they can put their pencil here, and then they can start collecting their data, okay? And then see if their prediction was correct, all right? Now down here, super fun. They get to design their own spinner. So it says use the ruler, straight edge, and crayons to design your own spinner. Now this activity sheet comes directly from our kit. So it says here, look at the station banner for ideas if you need. So what I did is I printed, you have a PDF copy of this. This is what the banner looks like. They're these vinyl banners that you hang next to the station. This is what it looks like. There's some really great information on here. And this is a link down here in case you want to see the banner on the website. In any case, they can look at this banner to get ideas on how to design their spinner. And the one spinner that I think is important to really focus on is this one right here, because notice how the purple is not colored together. Those two sections are separated. This is a great exercise, and some great thinking can happen here about asking them, well, do you think that's going to make a difference in when we start collecting data if we have the sections that are separated like that, or will it be the same results? There's some good thinking that's happening there. So just want them to see that they don't have to color all of their sections together. Okay, so then they're going to use the straight edge, and they're going to create their spinner. Okay, they're going to make a prediction about which one they think is going to get the most spins, and then they're going to test out their prediction and by looking at the results in the table that they've collected their data from. Okay, and then their critical thinking questions on that PDF that you have access to. The intermediate, I is intermediate. If you spin the spinner in part 1 20 times, about how many times do you think it will land on red? Wow, that's a great math problem for them to consider. Okay, and then explain why you designed your spinner the way you did, okay, in part 2. Okay, so to get them to think at a higher level. All right, so that's the activity for the intermediate level. Again, I highly recommend that you watch the section on creating your own spinner boards. This is the spinner board for the advanced level. If you do not have access to a printer, then once I go over these directions, you're going to watch the section on creating your own spinner board. That said, even if you do have access to a printer, I highly recommend that you watch that section anyway, because there's a lot of math that goes into creating these spinner boards, and your 4th and 5th grader is quite capable of creating their own boards. So you may actually want them to create their boards instead of printing this out. Okay, so there are 2 spinners here. They're actually going to be designing their own spinners. You're going to need crayons or colored pencils or colored pens in yellow, blue, green, and red. You're going to need a paper clip. That's going to be our spinner. And then you're going to need a straight edge. So this activity is all about probability and data collection. So probability is the chance of something happening. So in spinner 1, your child is going to design a spinner where blue gets spun 2/12 of the time and is the least likely. So notice how I've got these little tick marks here. Each one of these sections is 1/12. So there are 12 of those in the circle or in our hole, right? So they want to create a spinner where blue gets spun 2/12 of the time. So then they would be creating, okay, well, this would be 2/12 right there. Okay. So there's 2/12, and right here you can see 1, 2, all right? And is the least likely. Well, if this is the least likely and it's blue, can I have a yellow that's 1/12? Can I have a red that's 1/12? Or can I have red that's 2/12? Okay, so there's some thinking that's going on in the design of their spinner. Then they're going to make a prediction, which color do they think is going to get the most check marks, and then they get to collect their data. All right, there's a challenge question here that says simplify the fraction 2/12. So what's really nice and visual in this circle is that 2/12. So I'm not going to use the ruler now to make this easy, but let's see. If I do this like that, and then like this, and then like that, and then like that, right? So now I've got 1, 2, 3, 4, 5, 6 sections there, okay, that are exactly the same. And 2 of those 12ths makes 1/6. So if you simplify the fraction 2/12, you're going to get 1/6. Okay, equivalent fractions. All right, in spinner 2, they're going to design a spinner where red gets spun 1/3 of the time and is the most likely. All right, so now we need to talk about how do you figure out what 1/3 of that is. So I'm going to get my little manipulatives out here. Okay, and I've got 12 of these little macaronis because there are 12 sections going around my circle. Okay. So each one of these then represents 1/12, right? 1/12, 2/12, 3/12, and so on. Now, halvesies are super easy. So let's divide these into half. Okay, and there we go. There's 6 in here and 6 in here. This represents one of the 2 pieces. This is 1/2 of the whole. Let's use that information to do thirds. So now I'm going to create 3 piles here. There we go. This is 1, 2, and 3/3, right? So if each one of these is 1/12, then 1, 2, 3, 4/12 is equivalent to 1/3. That's going to help them figure out how many, 1, 2, 3, 4 sections needs to be, what color is that? We're red, so they're going to color that in red, and it's the most likely. Okay, so they need to keep that in mind. They can't color the rest of it yellow because that wouldn't work. And by the way, the banner, okay, does a nice job of showing different spinners, but I want you to see that they don't need to keep the colors combined together. Okay, and this is actually a good question to ask them, right? Does it matter? Okay, if the sections are together, will the results change? Is the probability different if we separate out the colors? Okay. And also here's a nice example down here of equivalent fractions. Okay, 3/12 divided by 1, 3/3 is equivalent to 1/4. So 3/12 equals 1/4. Okay, super cool. Okay, so that's, oh, and then there's the critical thinking questions. And the critical thinking question here for the advanced A is explain how you figured out how to determine 1/3 of spinner 2. Okay, good problem for them. So those are the directions for the advanced level. That said, again, I highly recommend that you skip over now to the section on creating your own spinner boards. If you don't have a printer, you're going to be designing your own spinner boards. And I am super excited about this section because there is so much math that we're going to do in this. Again, if you have older students, then they can design their own spinner boards. They're quite capable of doing this. Okay, so here we go. The beginning spinner, or the first thing that you're going to need to do actually is walk around your house and see if you can find an object, a circular object that you can easily trace that's about 3 inches in diameter. Let me see here. That one is exactly 3 inches in diameter. And you can even introduce the vocabulary word diameter. So a diameter is a line that goes across the circle and it passes directly through the center. You can have a line that goes across the circle from here to here, right? But that's not the diameter because it doesn't go through the center of the circle. Okay, so step number 1 is you need to find a circular object that you can trace easily. All right, when you've got that done, I recommend that you trace that object a bunch of times, okay, several times, because we're going to be using this to help us design our spinners. If you have access to a protractor, I'll show you how to do that. It's super easy with a protractor, but not everybody's going to have that. So we're going to do a lot of paper folding right now to get our boards designed. So the first question you need to figure out is, or your children need to figure out actually, and I do this with 4th graders and up, is once you have your circle like this, ask them, how can you figure out where the exact center of that circle is and be able to prove it? Okay, so then let them figure that out. Let them work on that problem. Okay, and they can get quite creative, frankly. Okay, but again, they need to be able to prove it. So it's not as easy as it seems. But what I'm going to do right now is I'm actually going to show you an easy way to do this, okay, to find the center of a circle. So here's your circle. Let me move this out of the way for a second. Here's your circle. We're going to fold it in half, okay, and crease that right there. Okay, so now we have 2 halves, right? 1/2 plus 1/2 equals 1 whole. It's a great fraction activity right there. Okay, so now we have a diameter. Okay, we know that that's going to go right down the center of the circle. But that said, where is the center? Is it here, or maybe here, or maybe here? We need to be able to find the exact center. So the next thing that you're going to do is you're going to fold it in half again. And these little fold lines, you're going to match them. So let's match that fold line with that fold line. Crease again. And then open it up. Okay. Not only is it a beautiful representation of fourths, okay, but right there, the intersection of both those lines is the exact center of that circle. That's important because we're going to need to know that in order to design our spinners. So the first spinner is actually going to be pretty easy because you're just going to, let me get this paper here. You're just going to trace your circle like that. Okay. And we're going to put this one on top here. Now you can either have a little hole through this so you can make a mark on the other end, or you can press firmly and you can see the indent on here. So where's my indent? There it is. Okay, so then I've got the exact center of the circle right there. From here, I can use my straight edge, right? And I can draw my line. There's my diameter. Okay, and I've got that one done. But now I need this one here. So you can use this again. And actually, you can put our little tick marks on here. There's a tick mark there. There's a tick mark there. Okay, and you can see where that tick mark is because of the fold line. So now we're going to draw this line right here. And there you have it. Spinner A done. By the way, I mentioned the protractor. Okay, you can use a protractor to do this as well. To create that right angle is 90 degrees. So if you put your little circle right there at the center of our circle, line up this line here, you can see there's 90 degrees. Perfect. And then you'd be able to, well, actually, do it this way. Okay, so here's your 90 degrees. Okay, and you can use the protractor to do that. Easy peasy. Okay, so spinner B is a little more challenging, and I love this because it really gets kids to think at a higher level. So how are we going to use this circle to help us turn this one, or our circle, into thirds? Let me draw this on here. Okay, first like this. Okay, so there we go. How are we going to turn that into thirds? So give them an opportunity to play around with this and see what they come up with. But I'm just going to show you one of the ways to do that. So I'm going to fold my circle into half again. Now, the reason why this is difficult is because there isn't a diameter that goes all the way across like that, right? But I'm going to do it here. I'm going to create that because now what I'm going to do is, and this takes a little bit of massaging, so I kind of like to make this so that these edges are easy to work with. We're actually going to fold this into, as best as we can, thirds. So it's not going to be perfect, and it's okay, but we're going to get it as close as we can. So if I fold that one that way and I fold this one this way, do they kind of match each other? Yeah, actually I did a pretty good job on that. Okay, so now I just folded that part into thirds. When I open this, how many sections do you think I'm going to have? That's a good question to ask them. I think I'm going to have 6. And I open it up and I have 1, 2, 3, 4, 5, 6. I do have 6 sections. So this is divided into sixths. So did I get my thirds? But what I need is thirds, right? Well, what's cool about this is that if you put this, see these sections right here, you can see quite clearly that 2 of these sixths is the same as 1/3. There are those equivalent fractions again. So now I'm going to put this on top here, and I'm going to draw my lines, my thirds, and then, and then I need the center of my circle. Let me make that indent there. There's my center. And then I get to draw my lines like this. Okay, how easy was that? And again, I'll show you quickly how to do. Okay, I'm doing this pretty quickly here, but you'll take your time. Okay, again, you could use the protractor to do this. Okay, if I put my protractor on here, I'm working with this line right here now. Put my protractor right like this. I'm going to line up the line on here with that. Oh, and this is called the radius. Okay, another good vocabulary word. Okay, and then you could see, boop, right up here, 120. So that will tell me exactly where to mark it. Okay, and then I've got those lines, and then I do the same thing to get that line on here. So easy peasy with a protractor. All right, so that is how you design your beginning game board. Now, I'm not going to go into how to design this section here, the graph. You can probably figure out that on your own. Okay, so that's the beginning level. Now, the intermediate level is actually, the first one is actually the same as the beginning one. So that one's done. Okay, but now we got to get through this one here. And this is divided into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So eighths. So how are we going to do eighths? Well, again, I would let your child, okay, figure out, see if they could give them the paper and see if they could figure out how to get eighths. But I'm just going to quickly show you. If you fold it in half, you've got halvesies. Okay, if you fold it in half again, you got fourths. Okay, and if you fold it in half one more time, okay, I didn't play with this paper as much, so it's a little bit more difficult, but okay. How many pieces do you think I'm going to get when I open that up? I should have 8, and there we go. 1, 2, 3, 4, 5, 6, 7, 8. Again, you can use this. I use this side. Recycle my paper. You can use this to help you with your little tick marks all the way around. Then we're going to get the center in there, and then just draw those lines in. All right, easy peasy. So the advanced activity is divided into 12ths. So I'm actually going to let you figure out how to use paper folding, okay, to divide this into 12ths. Again, you can use a protractor, okay. When you use a protractor, okay, you need to know that the circle is 360 degrees. So if we go back to this, let's go back to our thirds. Let me take the beginning one. So 360 degrees divided by 1, 2, 3 sections. That's how I knew that I needed to get to 120 degrees, okay, on my protractor. If I wanted to get into fourths, okay, let's say that there was a line across here, I wanted to do fourths. 360 degrees divided by 1, 2, 3, 4 sections is 90 degrees. That's how I know. That's how I knew that that was 90 degrees. And you can apply that same logic to figuring out, okay, 360 degrees divided by 8 is what? And that's what your angle measurement is going to be there, if you want to use a protractor. Okay, so you can see that designing your own spinner is an amazing math activity. And again, I highly recommend that if you have students, certainly upper elementary students can create their own game boards. And with some guidance from you, your second, third graders can probably do that as well. So have fun. So we always do a super fun hands-on project in all of our family math night events. And the project that I chose for our event is called Totem Pole. Now I had to adapt it to Totem Pole Home Edition because I had to think about the supplies that you might have at home in order to do this. So it's actually called Tabletop Totem Pole. And you can see here, this is the beginning of our totem pole. There might be more sections. You may end up adding more sections to this. There's 1, 2 here, okay? But what we're making, yeah, is a totem pole. Super fun. We are going to be studying geometry and a little bit of measurement, but mostly it's going to focus on geometry and specifically reflection symmetry. So, or it's also called mirror symmetry. So reflection symmetry is when you can draw a line down the center of your object and both sides are exactly the same. In other words, if I flipped this over like that, okay, it would match perfectly on this side here. Okay, that's reflection symmetry. So the first thing that you are going to need is to figure out your supplies. So I am hoping that most of you do have access to scissors. It's going to be a little bit easier with scissors. That said, it's not impossible without scissors. You are just going to need to fold your paper and make really crisp lines and then tear that really carefully. So you may want to do that part for your younger children. Okay. The next thing that you're going to need is an inch ruler. Now, if you don't have an inch ruler at home, we have created one for you that you can print out. Notice it goes to 16 inches. This is because if you want to end up measuring things that are longer, we had the space. You want to end up adapting this lesson and creating something larger than what we're going to be using. You have that there. Now, if you do not have a printer to print this out, this is where we get to be really creative, right? So this sheet of paper here is 8.5 by 11 inches. So if you know that this is 11 inches, can you figure out a way to add another inch on here, and then you could create your own inch ruler? Okay. Or maybe you know something in your house, the exact dimensions of something in your house, and you can use that to help you create your inch ruler. Or maybe there's a box in your garage that if you turn it over, sometimes underneath they tell you what the dimensions are of the box. I'm talking about shipping boxes. It might be 12 inches by 9 inches, and you can use that. But anyway, my point is that you can be creative and figure out how to make your own ruler. I know you guys can do this. Okay, so next, we're going to need, okay, so you're going to need the paper, obviously. Okay, this is the paper, 8.5 by 11. If you don't have blank 8.5 by 11 paper, this is where we get creative again. See this little section down here? I actually created that guy from a strip of paper that I cut out of a grocery bag. And I just cut it out right down here. All right. If you don't have a grocery bag, maybe you have a shopping bag that you can use. And here's one. What you need to do in this case is obviously when you cut it out, you're going to be designing using the blank side, not the side with the words on it. Okay. So there are options for you if you don't have paper this size. Okay. Next, you're going to print out, you have the PDF for you, is there for you for the tabletop totem pole project. Now I'm calling this the tabletop totem pole because it's adapted from an activity that, the original activity, which is simply called the Totem Pole Collaborative Project. And in that project, the totem pole sections are a lot bigger than the sections that we are going to be using. But I didn't think that most of you had access to poster board, okay, and some of the other supplies. So again, I had to adapt it. Now that said, if you do have access to the materials needed for the original version, I included the original version of the table tent for you. And in the PDF resources, there's a link, or actually right underneath this video, there's a link to the video of the collaborative totem pole project that I walk you through step by step. So some of you, if you have those, might want to do that project if you can. I'm calling these table tents because in our events, this is what we use. We have these table tents, and we put them up like that. And that way people on both sides of the table can read the directions, okay? I just kept it in that format. It was just easier for me to do it that way. All right, so here we go. I'm just gonna read through these are the directions for you. So the first one says, take a walk around your house. Can you find objects that have mirror symmetry. So I took a walk around my house, and in my kitchen I found this. This is my salt shaker. So you can see that if I drew a line right down the center here, one half matches the other half. If I flipped it over, okay, it would perfectly match the other half. I found quite a few things actually, but here's another one. So here's my bell. Okay, again, if I drew a line down the center, both halves would match. So do that. So take a walk around your house and see if you can find objects that have mirror or reflection symmetry. Okay. And then you'll be ready for this project. The next step is to cut a piece of paper into a strip 9 inches by 3 inches. Again, I'm trying to use paper that I think that you have available to you at home. So here's my 8.5 by 11 sheet. So you're going to move that out for a second. Measure. This is where the measuring part comes in. You can work with your child on measuring. Remember, when we measure, we start down here at this line. We don't start at the number 1. A lot of young beginner students will start measuring at number 1. And when we're using the ruler, we want to start down here right where this little line is. So we're going to measure 9 inches. So I'm going to take this down here and draw my little line right there. 9 inches, and I'm actually going to go down a little bit because it's going to be easier for me to cut this out then. So 9 inches, and then we want to measure the width is going to be 3 inches. So let me do 3 inches here. We'll mark that right there, and then we mark that again down here, 3 inches. Okay. And then you can draw your lines. And then we have our piece of paper. There we go. That's what you're going to cut out. When you cut that out, it's going to look like this. Okay. Now, with your kindergartners, we're going to be drawing in this little section here. And that's really not a whole lot of space. Kindergartners can do that, okay, with your help. That said, if you want to give them a little extra space, you can actually make this 4 inches by 9 inches instead. You're going to end up with something that's like this. Okay, it's a little bit, it's obviously taller, and that could easily be attached to your other totem pole sections. Okay, if you want your kindergartner to have a little bit of extra space, that would be one way to do that. Okay. So let me go back to those directions. All right, so the next thing that we're going to do here is use the ruler to measure, then draw 2 lines dividing the strip into thirds lengthwise. Okay, so this is lengthwise this way. And we want to divide it into thirds lengthwise. Well, how are we going to figure out what thirds are? What we need to end up with is 3 sections that are exactly the same. Okay, so can we look at this? If I divided my piece of paper, and this is a good problem actually for your children to work on. If I divided my 9 inches and I got 1 inch here, 2 inch there, 3 inches. Well, that's not going to work because then I got all this extra space. Will 2 inches work? 2 inches there, 2 inches there, 2 inches. Well, that's not going to work either. Let's try 3 inches. Okay, and they'll discover that 3 inches does indeed work. And of course, your older children can do a division problem. 9 inches divided by the 3 sections that we need is 3 inches. So we're going to do a mark there and a mark there. And I'm going to mark up here because it just makes it easier to draw straighter lines there. And then we're going to draw those lines like that and like this. There you go. Beautiful. Thirds, 3 equal sections. Nice. Now, this is the part that we're going to be designing in. So the next step is use the pencil to divide the center rectangle, this part right here, okay, in half. This is your line of symmetry. So I did try and try to figure out how I could do this where this would be a whole number. I mean, it is a whole number, but it could be when you divide it, it would end up being whole numbers. But the 8.5 by 11 didn't lend itself well to that. So we're going to work with fractions. So if I have 3 inches here, okay, and I need to divide that into half, how do I know what half of 3 is? Well, one way that you could do that, let me do this piece of paper here, is I could say, well, let me turn 3 into 2 plus 1. All right. What is half of 2? That's easy peasy. Half of 2 is 1. Okay. Well, what is half of 1? Half of 1 is half, because half plus a half equals 1. So half of 3 is 1 and 1/2. So now we measure 1 and 1/2 and 1 and 1/2, and then we draw our line. Perfect. That is our line of symmetry. Everything that we do on this side needs to be reflected perfectly on that side. Now, you can use crayons, pencils, colored pens to create your design in here. I highly suggest, though, that you do it with pencil first, and that way, and have an eraser nearby. That way, if you need to make corrections, you can do that, and then color it in. If you happen to have colored construction paper or colored, just colored paper at home, you can actually cut out your shapes like I did up here, and then glue those on. Okay. Again, if you don't have that or glue, you can just draw yours on like that, like I did down here. Okay. And then, let me bring this back. Okay. When your design is finished, tape the ends together to create a cylindrical tube. Isn't that a great word? By holding both ends flat on the table and taping on the inside. Do not overlap the ends. You do not want to overlap those ends, because if you do, if I overlap these, look at this. See how I overlap that? It is not going to fit. Oops, it's not going to fit on the top. Okay, so we want to make sure that when you fold it, let me get my tape over here. You can use masking tape too if you don't have clear tape. Fold it like that. So I'm going to, when I say fold it on the flat on the table, it's easier. And parents, you're going to need to do this with your little ones, because this is very difficult to do. But you'll fold it flat like this. You'll look inside there. It's hard for me to show you that, so I'm going to see if I can do it this way. Show you that you want to get those edges just perfect there, like that. All right. Now, what happens, oh, that one actually turned out really good. Usually what happens, let me see if I have my sample over here, is that you end up with this little pointy part right there. So it's not really a cylinder shape. So in order to flatten that out and make it a perfect circle, you're going to get strips of cardboard, so about 1/2 inch by 3 inches. And you're going to tape it on the inside. I'm going to do this on the outside so that you can see, but you see that line there? You want this to go right over the center of that line, okay, on the inside, so that, do I have a sample that's done? Yeah, I do. So that, can you see this, how I've done that on the inside there? Okay, and then that will keep it, I've been playing with these today, so it's not my perfect circle, but that should make it more cylindrical than having that little pointy part. And then that will fit nicely on top of here. Now, how are you going to know how to put these on? You're going to look for that line of symmetry. See this line? Oh, it goes all the way down. You're going to match your lines of symmetry just like that. And to get you started here, I always have this on my line of symmetry. There's my line of symmetry. I'm going to match it with this line of symmetry. Match it up like that. Perfect. See how that matches? And then you're just going to go around, you're going to add tape, tape to the rest of this. Start from the front and work your way back. Just in case you get a little bit of leftover stuff, it ends up in the back and not in the front. So there we go. Okay, tabletop totem pole. Super cool. And then let me see, did I go through all the, tape a small piece of cardboard over the tape. This will help maintain a cylindrical shape. When all the sections are complete, tape them together to create your amazing tabletop totem pole. And what a fabulous centerpiece for your kitchen table that makes. And all of your family is represented in that. That's my favorite part right there. So, there are some questions, some math questions. Of course there are math questions that go with this activity. And you have the PDF for that. I included, if you end up doing the original activity with the poster board, I have all of those here for you, okay? And I also have the answers for you. And I have the answers for the tabletop one that we just did. Now, these questions don't go at the end. They actually go as you're doing the project. So read the questions first because you're going to be asking your children these questions as they complete the activity. So at the beginning level, they're going to describe the shapes that they used in their design. Talk to them about the shapes that you're using and the attributes. You know, oh wow, that's a triangle. How many sides does the triangle have? And so forth. Can you find a shape that has exactly 4 sides? How about 5 sides? Did you include any rectangles or triangles? Okay, so those are really great questions to ask. And then look around the room. Can you find objects that have mirror symmetry? And you actually did this already when you went on your walk. At the intermediate level, if the poster board strip is 9 inches long, let me get one that doesn't have those lines on it. It's 9 inches long, and you need to divide it into 3 equal sections lengthwise. How long will each section be? How did you figure it out? Okay, so we're going to let them try and figure out how to divide that into thirds. And then at the advanced level, if the length of the poster board strip, and actually that shouldn't say poster board strip, it should just say strip. That was my copy paste from my earlier version. If the length of the, and I will fix that so that when you print it out, it will not be like that. But if the length of the strip is 9 inches and the width is 3 inches, what is the total area of the strip? Okay, how did you figure it out? So now they're going to multiply, right? 9 times 3. If we want our totem pole to be 1 foot tall, how many 9-inch by 3-inch strips will we need? Okay, so if we want it to be 9 inches tall, okay, how many of the 3-inch strips will we need? Okay. 1, 2, 3, or 3 times 3 is 9. How many for 2 inches, for 2 feet tall? How about 3 feet tall? Do you notice a pattern? Can you explain that pattern? Okay. Just beginning questions that you can ask. You may come up with a whole bunch more, and that is fabulous. So we want them to get them to think mathematically through this project. Now I have one more thing to talk about, and that is, this is actually a fabulous STEAM project. STEAM stands for Science, Technology, Engineering, Art, and Math. And what you would do if you wanted to turn this into a STEAM project for your, second graders, they might be able to pull this off, a little bit of help. Certainly your third graders and up, is don't do any of that stuff that I just talked to you about. You're going to have them research what totem poles are, the history of totem poles, if you will. Then they're going to gather supplies, their own. They're going to figure out what they need. Again, they might need a little bit of guidance from you, but figure out the supplies that they need. And obviously we're going to be using paper kinds of supplies, but do not use toilet paper or paper towel rolls. Okay. Don't do that. And then they get to create their own math problems, similar to the ones that we went over just a minute ago. Okay, this is a fabulous STEAM project if you want to turn it into that instead. So there you have it, the Tabletop Totem Pole project. Have fun.
So the last thing that I want to talk to you about are our What Do You Notice posters. We always have one of these at our Family Math Night events, and this is one of the posters that I did at an event last month. Okay, and what I love about these is that it lends itself really well to multiple entry points. And what I mean by that is you can have a kindergartner look at this and figure out something mathy to say, and you can have a 4th and 5th grader look at this and figure out something mathy to say. A kindergartner might say, oh, I see circles, I see squares, I see 4 circles in every square. A 2nd or 3rd grader might be doing repeated addition, so they're noticing, or counting, maybe skip counting by 2s, or maybe even 4s. 4th and 5th grader might be working on their multiplication facts, so they're going to figure out how many circles there are all together, or how many squares there are all together, and so forth. So I really love these What Do You Notice posters, and we have a lot of them available for you to look at on our website at familymathnight.com. under the resources section, but I believe that we also have a button underneath here, or a link underneath this video, that you can quickly access those as well. So there you have it. There's your Family Math Night event. I wish you great success with your event. If you would send photos, I would love to see how your event went. If you have questions, or comments, my contact information is at the end of this video. Have a fabulous event.